In this lesson, we're learning how to add and subtract rational expressions. When adding and subtracting fractions, we need a common denominator, and that involves finding the least common multiple between the denominators. So before jumping into doing this with polynomials, we'll start with numbers. So we're going to find the least common multiple between 8 and 12. So to do that, we need to find the prime factorization of both 8 and 12. So 8 is 2 times 4. And 4 can be broken down further as 2 times 2. So really, 8 can be written as its prime factorization as 2 cubed. Then for 12, 12 can be written as 4 times 3, and 4 is 2 times 2. So 12's prime factorization is 2 squared times 3. Then to find the least common multiple, what we need to do is find the product of the prime factors to the highest power. So what that means is we look at the prime factorization and we look at all the 2's. So the highest power of the 2's is 3. So in our least common multiple, we need a 2 cubed. Then we also have 3's. So the highest power of the 3 is just 1. So in our least common multiple, we need just 1 3. Then the least common multiple is 2 cubed, which is 8, times 3, which is 24. We'll do one more example. So the least common multiple between 24 and 36. So 24 can be factored as 6 times 4, which is 3 times 2 times 2 times 2. So 24 can be written as 2 cubed times 3. 36 can be factored as 6 times 6, which is 3 times 2 times 3 times 2. So 36's prime factorization is 2 squared times 3 squared. Then for the least common multiple between these two numbers, we look at the highest powers of the factors. So the factor of 2 has a power of 3 here and a power of 2 here. The highest of those is the third power, so our least common multiple would have a 2 cubed. Then we look at the 3's. There's 1 3 here and there's a 3 squared here. So the highest power there is squared. So our least common multiple needs a 3 squared. That means our least common multiple is 2 cubed, which is 8, times 3 squared, which is 9. So 72 is our least common multiple. Now we will practice doing this with polynomials, and what we need to do is factor each polynomial. So 2x plus 4 factors as 2 times x plus 2, and x squared minus x minus 6 factors as x minus 3 times x plus 2. Then for our least common multiple, we need to take the highest power of each factor that shows up. So we have a factor of 2, that's part of our least common multiple. We have a factor of x plus 2. The highest power of that we see is 1. So we need a factor of x plus 2. And then we have a factor of x minus 3, which also has a power of 1. So the least common multiple is 2 times x plus 2 times x minus 3. For the next example, we again start by factoring. So the first expression can be factored as x plus 4 times x minus 1. The second expression can be factored as x plus 4 times x minus 2. And the third expression can be factored as x minus 2 times x minus 2, which is x minus 2 squared. Then for our least common multiple, we look at all the factors of x plus 4. There's a power of 1 and a power of 1. So the highest power is 1. So for the least common multiple, we have x plus 4 to the first power. Then we look at the x minus 1's. We have a highest power of 1, so x minus 1 is a factor of our least common multiple. And then we look at the x minus 2's. So I have a power of 1 here, and I have a power of 2 here. The highest power is 2. So for our least common multiple, we'll have x minus 2 squared. Okay, so I have, for the next step, we are looking at adding fractions with numbers. I have a 4-step process listed here if you want to pause the video and jot down those steps. The first step, we need to find the least common multiple of the denominators. So we need to find the least common multiple of 3 and 4, which are the denominators. If you want to pause the video and try that, the answer we get is 12. So the second step is to get the common denominators by multiplying by an identity. So what that means is we need a denominator of 12. In order for 3 to turn into 12, we need to multiply it by 4. So we are going to multiply by 4 over 4, which is allowed because 4 divided by 4 is just 1. The second fraction, to get a denominator of 12, we need to multiply by 3. So we multiply by the identity 3 over 3. Our next step is to multiply those fractions. So 4 times 2 is 8, divided by 4 times 3, which is 12. Plus 3 times 3 is 9, divided by 12. Step 3 says our next step is to add. So we add straight across the top. 9 plus 8 is 17, and the denominator stays the same. If you can simplify any further, that's the last step. But for this problem, we are done. Now we're going to practice adding two rational expressions using that same technique. So we need to factor both of those expressions. So the first fraction is actually all the way factored. So x over x minus 1 is as factored as we're going to get. And then plus, the second one can factor is 2x minus 1 over x minus 2 times x minus 1. Now for our least common multiple, both denominators have an x minus 1, but the second denominator has an x minus 2. So our first fraction is missing that. So what we need to do is we need to multiply our first fraction by x minus 2 divided by x minus 2. So x minus 2 divided by x minus 2. When we multiply that, we end up with x times x minus 2 divided by x minus 2 times x minus 1, and plus the second fraction is unchanged. Now that we have the same denominators, we can add across the top. So what that becomes is x times x minus 2 plus 2x minus 1. And that is all over the denominator of x minus 2 times x minus 1. Now our next step is distributing and combining like terms in the numerator. So we're going to multiply the x. We're going to distribute it, so we'll have x squared minus 2x, and then we still have 2x minus 1. And we still have our denominator of x minus 2 and x minus 1. The minus 2x and the plus 2x cancel, and we have x squared minus 1 in the numerator. Now you can factor the numerator. Which factors as x plus 1 times x minus 1. So x plus 1 times x minus 1. And then we have x in the denominator, x minus 2 times x minus 1. Now to simplify that fraction, we can cancel the factors that are in both the numerator and the denominator. So for our final answer, we have x plus 2, or x plus 1 over x minus 2, And again, we need to state the restrictions on the domain. So here x cannot be 2, and from our canceled factor, it can also not equal 1. And that is the final answer. For the next problem, we do the same thing. So the sum of two rational expressions in simplest form, our first step is to factor both of those polynomial fractions. So one is x plus 1 over x minus 1, and the second one is negative 2 over x times x minus 1. Now for the least common multiple for a common denominator, both denominators have an x minus 1, and one of them has an x. So this fraction needs an x. So what we're going to do is multiply by x over x. I'm going to condense a couple of those steps, so now we have x times x plus 1, and I'm going to combine this all into one fraction right away. So we have minus 2, and that is all over x times x minus 1. Our next step is to multiply, so we have x squared plus x minus 2 divided by x times x minus 1. If we factor the numerator, that is x plus 2 times x minus 1 divided by x times x minus 1. If we cancel out the factors in the numerator and denominator that repeat, we are just left with x plus 2 divided by x, and x cannot equal 0, and it cannot equal 1. If you want to try the next problem on your own, it would be a good idea to pause the video now and try it. To do the second problem, part B, we need to start by factoring each fraction. So the first one factors is x over x plus 2 times x minus 2. And the second fraction factors as 1 over x plus 2. To get our common denominators, the second fraction is missing the factor of x minus 2, so we're going to multiply by x minus 2 over x minus 2. What we get as a result is x plus x minus 2 over x plus 2 times x minus 2. When we combine like terms in the numerator, we get 2x minus 2 over the same denominator. We can factor a 2 out of the numerator to get 2 times x minus 1, and that is divided by x plus 2 times x minus 2. Since none of the factors in the numerator or denominator are the same, we are done, that is in simplest form, and we just need to specify that the domain restrictions are negative 2 and 2. For the rest of the notes, continue to part 2 of the video.